Okay, looking at number 10, we know the mean is 13.3 and the standard deviation is 3.4. What is the probability that American will consume less than 9 pounds of chocolate next year? So what we want to do is we want to put this in StatCrunch using technology on this one, not looking up at the table. If it wants you to use the table, you will it'll give you the link to the table. Okay, so what we want to do is calculate it using technology. So we said the mean is 13.3 and the standard deviation is 3.4. So we want the probability that it is less than 9. So if you hit compute, you will get 0.1029, which rounds up to 0.1030. Okay, and then the next one, what is the probability that an American will consume more than 11 pounds? So more than 11 pounds, you just put in 11 and hit compute, and you get 0.7056. And then the next one, what is the probability that an American will consume between 10 and 14 pounds? So first we're going to look up the probability up to 14. And you get 0.5816. And then from 10 to 14. So below 10 we need to subtract out. So we need to do 0.5816 minus 0.1659. And that is where you get the 0.4157. What is the probability that an American will consume exactly 12 pounds? Now, if we talked about that, that would be 0 right at 12 when you're doing this type of problem. And then, what is the annual consumption of chocolate that represents the 80th percentile? And basically, I copied this in wrong when I copied the number over wrong when I did the calculation. They gave me the right answer. I just copied it wrong, which is very common when you're doing stats, just because you have all these decimals. Let me put this in again. I don't know why I closed it out. Try to keep it open the whole time so you don't have to keep putting the numbers back in. So we want to do 0.80 and you get 16.2 because you're rounding to the 10th. So that's all you do on that one. Question number 11, I believe, is fairly the same. Question number 12 is basically, it wants you to, for one standard deviation, the standard deviation is 85. So you would do one below it would be 1970 minus 85. One above it would be 1970 plus 85. On the second one, two standard deviations, you can do this two ways. Two standard deviations would be 170. So add 170 to the mean and subtract 170 to the mean. Or you can just add 85 to your one standard deviation. Keep adding 85. For the third one, add 85 to this one and add 85 to this, subtract 85 from this number. Or you could say 3 standard deviations, do 85 times 3, and I believe that's 255. So add 255 to this and subtract 255. So, what if the warranty costs $23.10? Well, if you look, $23.10 is above this, and this is 3 standard deviations. It's very rare to be more than 3 standard deviations from the mean. So that's why we would say, due to the fact that it is much higher than average, because it's more than 3 standard deviations from the mean. If it was 1 or 2, then it would be a reasonable price, a little bit higher, but 3 means it's much higher. It's not very normal. Okay, question 13. These are similar calculations, but let's look at D. There are 14 televisions on the site. How many televisions are within a $800 budget? So what we need to do is, first we need to open StatCrunch, I closed it out again. Please keep it open when you're working. I don't know why. Just minimize it so you don't have to keep going back. I guess it's just a habit for me to close it. So the mean is 820. The standard deviation is 170. And it said there are 14 televisions on the site. How many televisions are within an $800 budget? So within means less than or equal to 800. So if we compute 0.4532, 0.4532 or 45% of these will be within 800. So if you take 0.4532 and times it by 14, I think, let me check, because I didn't write this one down. 0.4532 times 14 is 6.3, but we're going to keep it at 6. We'll round into the nearest whole number. What this means is the probability of getting a TV that is less than or equal to $800, there's a 45% probability that you will get that. So 45% of the TVs would be with less than or equal to 800. If we have 14, take 45% of those, so 0.4532 times 6. Okay, number 14, interval scores is the same thing. Remember, 687, add 45, subtract 45, 687, 2 standard deviations, 45 times 2, so add 90, subtract 90 from the mean, and then 3 standard deviations would be 135, add 135 to this number and subtract 135 from that number. So I think this one is basically the same thing that we have been doing. You have your mean and your standard deviation. You just put it into StatCrunch. 80th percentile, we can do that one because we haven't done many of those. But the mean is 55 and the standard deviation is 6. And we want the 80th percentile, so we put 0.80 over here. And you get 60.05. 60.05. Question number 16 is basically the same thing. Work it the same way we've been working these. And I believe I've worked one like this too. Remember, when you're doing N, P, and Q, if you want less than or equal to 9, you've got to put in 9.5. You've got to have kind of a range. And then if you want it equal to 9, you have to use, when you're putting it into StatCrunch, you have to use a range of 9.5, get that probability, and 8.5, get that probability, and subtract. Here you would put in greater than or equal to 15.5. And here you would do 19.5, get that probability, and 8.5, get that probability, and subtract. Let's see, 18. I believe on these, you're saying between 10 and 13. Remember, this is going to be a range. So what you have to do, remember, N is 21, P is 0.329, and Q is 1 minus 0.329. You have to get your mean by taking the 0.329 and times it by 21. And once you get that, your mean, I believe, is 6.2. I don't even know if I wrote the mean down on this one. Yeah, I did. The mean is 6.91. Okay, and then you have to take N times P times Q. 0.329 times 0.671 times 12.60. Hold on, I'm telling you wrong. N times P was 6.909, so times that by Q, which is 0.671. And you will get, for the standard deviation, you're going to get, 2.08, and for the mean, you're going to get 24. 0.78, I believe, for 6.218. So you put those in, and then for your range here, you're going to do 9.5 and then get the probability, and then do 4.5 and get the probability, and then you're going to subtract those. Same thing here, 13.5 and 9.5. And then what is the probability of exactly 6 adults? Do 6.5 and then do 5.5 and subtract those probabilities. Let's see, 19, same type of problem. And then 20 is the same type of problems too. So that concludes section